Good evening, ladies and gentlemen. I'm Lakmal Isuru, the chairman of Building Service Engineering Section Committee. Today we are going to start one of the important, I call this workshop, with a limited participant for the industrial needs, about the needs of energy efficient smart homes and the buildings. We are sponsors by the Orange Corporation to this program to deliver good technical sessions for our engineers who are practicing building service engineering. So I, as a chairman of the Building Service Engineering Section Committee, I just want to highlight about this section committee. So Building Service Engineering Section Committee is one of the section committee in the ISL, Institute of Engineers Sri Lanka. So who have all civils, mechanicals, and electricals disciplines engineers are working with us. So, so the reason why the building service engineering is now is more attractive, because now construction now moving forward in Sri Lanka as well as in the all over the world. So now once the buildings are constructed, the building services are real needs for these buildings. So as far as this concerned, the energy is a highly key key performance index for the current buildings. So having said that, so Building Service Engineering Section Committee is here for serve the building service engineering community the best service for the membership as well as the nation. So today we start our first program for the session, ISL session 23-24. So with that, so I warmly welcome for the our distinguished speaker, Mr. Tom Vanden Bush. Sorry about your name, is not way to pronounce anyway. And also I warmly welcome the Oral groups who sponsors for this program to deliver the wonderful technical session for our engineers, as well as I welcome the members of the ISL Council who participates for this program to see the importance of this program, as well as all the engineers who are practicing for the building service engineering. I welcome. So I invite my team who are organizing this event. So normally we have the team to organize for the particular. So I invite Engineer Kaushal Patirana to start this program. Thank you.
Thank you, Chairman. Good evening, ladies and gentlemen. I'm Kaushal Patirana from the Building Service Engineering Section Committee. I warmly welcome you all to the very first event organized by Building Service Engineering Section Committee for the session 2023-24. Today's workshop will be a very special one. It's a collaboration between Building Service Engineering Section Committee and the Oral Corporation. So thank you guys for supporting us to organize this one. So our topic is today, how to design energy efficient smart buildings. As we all know, smart building concept, IoTs, artificial intelligence, retrofitting are the blooming topics these days. So among them, smart home is a very hot topic. So I'm pretty sure that all of you are familiar with this stuff. So smart building is a building that communicates and interact with subsystems such as AC system, electricity, lighting, security, etc. So today objective of the workshop is to give an introduction of designing energy efficient smart building with Q-bus system. So with this thing, I would like to introduce our speaker today, Tom Vanden Broeke. He's a experienced entrepreneur, board advisor and investor, and he's from Belgium. So further, he's a CEO and owner of the Qbus NB. Qbus developed reliable and affordable solutions for smart homes. So he has a law and economics degree from Gwent University and an MBA from Harvard Business School. So further, Tom is a board member and investor in few other companies like Sumam, Semple, and Sensor, and all of those companies are related to smart concept. So with this, let's give a warm welcome to our guest speaker today, Tom. And one more thing, guys, you can raise your questions during the presentation or at the end of the presentation. Over to you, Tom. Thank you.
Thank you very much. Thank you all for giving me the opportunity to speak here a little bit about the need for smart homes and smart buildings, mostly in energy efficiency focused smart homes and buildings. And thanks for the introduction. It's always interesting to hear that about yourself. I have a short agenda here, if it wants to move. Yes, I have a short agenda. So the why on smart homes and buildings, I think lots of you people know that already. I'm not going to spend too much time. General energy trends. I have given a presentation the last couple of months in different European countries about general energy trends. And Sri Lanka, okay, it's not Europe, I know, but I'm pretty sure that this is an evolution that you will see happening here as well. We'll go into that. We will talk about the need for energy management systems. Why do we need energy management systems and how does that compare to smart homes and buildings? But a little bit about the solutions that we have with Qbus, and then there's plenty of time for Q&A. I'd like to start with this slide. It's a car. It's a simple car, and everybody thinks it's normal in your car that when it gets dark outside, that the lights go on. That it starts raining, that your windshield wipers start working. That when you get into the car, that you can change the heat from the left-hand side or the right-hand side, the front or the back. Yeah, you leave your car, you push one button, everything closes. You don't have to turn off the radio, turn off the airco, close the window. Everything is closed automatically. Yeah, in a home, which is a lot more expensive and a lot more an important asset in your life. This is not the case. In a home, you have to turn on the lights when you want to. You have to open the door. You have to arrange the temperature individually. You have to arrange the ventilation individually. The screens, when it starts, being too windy, you pull up the screens. That is, it's an evolution that inevitably will happen. If it happens in cars, it will happen in homes as well. So what is this purpose? Why is there a need for smart homes and buildings? It's all focused on sustainable control. People, if you talk to people and you say, we need to be energy efficient because you have to become sustainable. I mean, if we turn off the airco in this room, we're very sustainable, but we're not very comfortable. Yeah? People are used to comfort. Vice versa, if we have the airco running in this room continuously all day, even if there's nobody here, yes, there's lots of comfort, but it's absolutely not sustainable. So we're focusing on sustainable comfort. And there's a difference between homes and buildings. In homes, sustainable comfort has to do, obviously, with energy efficiency and the comfort of the people who live there, but also with the upgradability of your home. When you are just the two of you, you're recently married and you have no kids, you have different requirements of what your home should do on how you live versus having a family with 3 or 4 kids versus being an elderly people. If you're old, maybe you want to have a remote button. Maybe your sensor in the bathroom that turns on the light should also indicate that there has been no motion for a couple of hours, sending out a message to next of kin, to the neighbors who come and visit because maybe you fell out of your bed when you're 80 years old. Yeah. In smart buildings, it's again sustainable comfort, but there's other requirements as well. The comfort is not for the users, the comfort is for the people working there. I think everywhere in the world there's a war for talent. Also in Sri Lanka, there's a war for talent. If you hire people, young engineers, like you guys are or were young engineers, If you hire them, you put them in the basement in a dark area, it's going to be very easy for them to run away to another location. You have to provide comfort for the people working in your buildings, in your offices. Same thing if you build hotels, you want to have comfortable rooms for the guests living there. The upgradability is the same question. The quality of air, very important. It's been very important for 10 years. We have been installing or basically selling solutions that regulate air quality that regulate the ventilation based on air quality. We measure CO2, humidity, temperature, and based on that, we adjust the volume of fresh air coming into the room. We've been doing that for 10 years. This now became very important with COVID times. COVID times, suddenly people started thinking, okay, the people next to me, if they sneeze or they cough, it might be that there's certain bacteria, viruses happening or viruses spread in the air coming to me. So a healthy air quality, a healthy environment, very important, also part of smart buildings. Flexibility. Again, with COVID, we saw, especially in Europe, I heard here as well, we saw people working at home. Not everybody came to the office every day anymore. Sometimes they come, sometimes they don't come, but in your big office building, you have rooms, you have meeting rooms, you have individual offices. You don't want to have the airco running in an office where nobody is, if that guy is working at home at that point of time. You don't want the lights to be on, yeah? On the other hand, you want to make sure that when they get there, they have this comfortable, healthy air, sustainable environment. Now, how do we turn homes and buildings into smart homes and buildings? It was already touched upon during the introduction. It's the integration of electrical subsystems. We integrate lighting, HVAC, IP cameras, audio systems, garage doors, energy management systems. We integrate all of these things together because in most of these installations, 1 + 1 is 3. If you have screens and HVAC that are both integrated together, if the sun is shining in, we have a lot of new projects where you have a lot of windows, a lot of glass. The sun is shining in, you want to prevent from overheating, you automatically close the shutter, you automatically close the screen so you don't have to run the airco at full force. These are very relevant. It gives you the comfort and it gives you sustainability. Couple of examples, not going to take too long, but a couple of examples of smart home functions could be very simple. An all-off button at the front door. You leave your home, push all off, all the lights go off, the airco goes to 26 degrees, etc. Yeah, the alarm is activated. Could be that I'm driving home and I'm turning on the airco already with my phone. The motion detector, as I was explaining, the motion detector in the bathroom turns on the lights, but also identifies that there has been no motion when we would expect motion. So in this elderly home, in this home where you have elderly people living, they will send a message to next of kin or to the neighbors. And what we do a lot of times now, and this is popping up in the last couple of months, maybe 1 year, is energy. Energy, and I will talk a lot more about that, but energy is about receiving messages when you're consuming too much. Or is active load balancing of smart vehicles, of electrical vehicles, not smart, electrical vehicles. We'll get into that later. Commercial applications could be the same, but are then again a lot more focused on commercial functions. Access control, flexible access control, who has access to which room in a building at what point in time. How can you easily allocate access rights and retake access rights? Could be facade lighting with DMX control, with RGB LEDs, with everything that you want. The big difference for us as a supplier, because we produce these products, big difference between smart homes and buildings is that in the smart homes we are not very much involved in the commissioning, the configuration, etc. The installer and the system integrator is doing that. In bigger buildings, there's a lot more service, a lot more support that we have to give in terms of project support and configuration support. Now, let us think a little bit about the general energy trends. As you can see, the world is in flux. The energy market is changing. It's cracking, it's changing. It is. We are basically experiencing a very key turn moment in energy worldwide. First of all, there's the energy transition. Right now in Dubai, there's another sustainability forum. The COP is happening in Dubai, where they try to keep the heating of the earth up to 1.5 degrees, which is impossible anymore. If I can believe the scientists, if we can get to 1.8 or 2 degrees, it would be fine. But that's stuff that we see. We see floods, we see droughts, we see rains, we see mountains, basically snow melting, ice caps melting, and we see a heating of an overall overheating of the world. We need to move away from fossil fuels. It's been a slogan that's been mentioned for a long time, but now, especially in Europe, you see people putting it into law, countries putting it into law. In Belgium, for instance, you cannot buy a vehicle which is not electrical anymore. You have to buy a vehicle that's or hybrid or electrical as of the 1st of July of this year. So we see a huge increase. In Germany, it's exactly in Germany, you cannot have heat pumps anymore that cannot be controlled, that are not electrical. So no more gas, no more fuel, and they have to be able to be controlled by an external system. Why? Because then even the suppliers, the overall suppliers of energy could take control and could reduce or could basically play with the energy demand of households. We'll get into that later. And we see very diverse installations. It's not anymore one supplier generating energy, delivering it. Everybody becomes supplier. Everybody, again, I'm talking mainly with my viewpoint from Europe. We have lots of people having solar panels. We have offices building, having windmills, small windmills on the roofs in front of their offices. They are generating energy. They're generating energy, they're over-generating energy that they have to distribute back to the net if they don't consume. It's all kinds of challenges. And lastly, there's little or no knowledge of this whole shift in energy, nor at the consumer level, but even not at the installer level. We see that a lot of installers back in Europe do not have the knowledge of what's happening in terms of electricity or energy consumption, what are the best solutions to put in place, how should they manage it, all these kind of questions we are getting all the time. So when we look at the general energy trends, as I was saying, we have very ambitious goals, yeah, and the focus is more. So let's become more economical. Let's not waste energy. Let's not run the airco if nobody's there. One focus point. More green. If we use energy, let's make sure it's renewable energy. It's solar, it's wind, it's not fossil fuels. And then thirdly, more smart. Let's become more smart. Let's be more efficient in controlling the energy that we're consuming. If we look at the market, this is the worldwide market of energy, of energy in general. The red dot is the total energy consumption today. There's a large focus on reducing the big red dot. We have to consume less energy. Yeah, that is a focus. On the other hand, you see the blue dot inside the big red one. The blue dot is the electrical energy, is the parts, the proportion of electrical energy in the total energy consumption. We will see that there is a huge increase in electrification. There's going to be a lot more electrical energy. In total, energy consumption will decrease, but the electrical energy will increase. And the third thing is that it will be a lot of electrification in the residential area. So today, residential is only 1/4 approximately of total electrical consumption. It will be close to 2/4 in the future. The good news is that electrical energy you can control, you can manage it, you can have energy management systems running into that. I have, again, these are slides back from Belgium, but it's giving you, it's very actual data. We see a lot of electrification in heating systems in the market. We see it in Belgium, we see it in Germany, we see it in the Netherlands. Netherlands, they have gas. They're filled with gas. There's lots of gas in the Netherlands under the ground, but they cannot use it anymore because houses start cracking. They are taking out all the gas, so the ground layer is crumbling, and they are stopping gas exploration, which means they also are moving to electricity. Obviously, in Europe, we have lots of implications of the war between Ukraine and Russia. We are getting a lot of gas from Russia. Russia is not willing to give us gas for free anymore. They're not happy campers, so we have to pay a lot of money for the gas. That's also one reason that we have to move away. So moving away, and it's also legally obliged, you cannot build a home in Belgium, Netherlands, Germany anymore with which does not have electrical heat pump. No more gas-based heat pump or oil-based heat pump. It has to be electrical heat pump. This is the evolution of electrical vehicles. This is specifically the Belgian market. We currently have 100,000 electrical vehicles in the market. That's not a lot. I think we have about 2 million vehicles. What is amazing here is the increase, is the scale. It took 10 years to get to 100,000 vehicles. And it takes 1 year to get to 200,000. So we have really a hockey stick approach. And what I'm trying to show here is that once the technology is ready, it can go really fast. I don't have to explain you guys that, but this is a picture taken in the year 1900 and Fifth Avenue in New York. It's hard to see from where you stand. It's even hard to see for me, but the red dots, it shows a car. This is basically, it's all horses and carriages, and there's one car in 1900. This is the same street in 1913. It's 13 years later. There's one horse, and it's all vehicles. So it's the rate at which technology can accelerate or change your life and your living environment is pretty impressive. Now, as we're moving into this energy transition, there's quite some challenges. Quite some challenges compared to the way we work and live today. This is a graph showing the energy consumption, the energy demand for 1 week in Belgium in 2006. You can see very clearly the Monday, Tuesday, Wednesday, Thursday, Friday peaks, and you see the weekend. Yeah. So for the company providing energy, it's pretty straightforward. It's pretty predictive. How could they provide energy? They provide energy based on nuclear power. Nuclear power, it's a fixed outcome of energy. You can basically supply most of the energy via nuclear. And we had semi-flexible power plants, gas-powered power plants to give this fixed energy provision on top of that. The gaps were filled with smaller power plants, gas engines, gas turbines that were turned on when needed, and with hydro. We have a little bit of hydro as well in Belgium to fill that up. That's the year 2006. Pretty straightforward. The blue line is the energy demand in the same week in June 2022. There is absolutely no predictability. And why do we have such an energy demand? Because we have lots of people having solar panels on their roofs. And with solar panel, you're generating yourself. You have certain demands that you don't have anymore. So you have unpredictability. It's good that we go to solar. Total energy consumption will reduce, or at least from fossil fuels. But it is the predictability is leaving. On top of that, the way energy is generated is changing. We're moving away from nuclear to renewable energy, to wind and to sun. But you have no idea when the wind will be blowing and when the sun will be shining. Here you do, not in Europe. Yeah? So we have unpredictability in the demand. We have unpredictability in the supply, which is not a great situation to be in. Now, this is only electricity. So let's take a look. This is electricity, 1 year of electricity, the consumption or the demand, the weekly demand of electricity. If we put gas on top of that, this is the 1 year of gas demand. As I was telling you, we are moving away from gas, from fossil fuels towards electricity. So this gas, it's not going to disappear overnight. This gas has to be replaced by electricity, mainly. A lot of it has to be replaced. Yeah. Obviously, there's a factor. It's not a full range, about 1/3. But still, we will have to add this demand to the electricity consumption. We're not done yet. On top of that, this is the variability in pricing. The variability in pricing, I think, is a European factor because of the war with Ukraine. I think here you might have less variability in pricing in normal economic times. But that's something else we have to take into account. So as a conclusion, in the energy market, we see a huge variability of supply, of demand, and of pricing. So people have no idea anymore when, who will be using what at what price. It becomes a black box. Second challenge that we have is what we call the renovation rush. So I was saying that we have new builds in most of the European countries, most of the Western European countries. You have to build with energy efficient technologies, with electrical heat pumps. You have to get solar panels. You have to have solar boilers and all these kind of things. That's new builds. But also now they are pushing the renovation rush. If you have a house, even if you live there or whatever, you have to shift that house to a better level of energy efficiency every 5 years. So approximately every 5 years. So if you have a house energy category D, which is everybody's house today, mostly, you have to go to category C by 2028, and to category B by 2035, and to category A by 2040. So basically, we have to triple the rate at which we are renovating houses back in Europe to get to that level. So there's going to be lots of demand for, again, energy management systems and energy efficiency solutions. So variability and renovation rush multiplicator that is adding to the market. So when we look at all this, obviously there's a growing need for energy management. And why is there a need for energy management? Because what is happening on top of that in terms of the functions and the tools that you have in your house, a house is not just using energy to turn the light on. Yeah, it becomes a complex story. You have electrical vehicles. Electrical vehicles have a battery. That battery has to charge during the day. If we would start talking about vehicle to grid, when the battery is charging at the office during the night, during the day, and you come home, you could discharge the battery of your car to use inside your home. Yeah, that's an option. And obviously, because of all this additional electrification, we have solar panel installations. People have solar panels with inverters that they use to generate to consume electricity, but also to charge their batteries. There's thermal buffering. Your solar panels in a residential environment, solar panels are generating during the day when you're not at home. So when you're not at home, what do you do with the overcapacity of energy that you're generating? Giving it back to the net is not an option. It used to be an option. Back in Europe again, it used to be an option until about 2 years ago, because you could use the net as a major battery. You were generating during the day. You had a meter, we call this the turning back meter, right? So every kilowatt that you could put back in the net, you could buy it back in the evening, did that kilowatt, and bottom line, you pay €0. The problem is that the capacity of the electricity network is not up to par. It cannot deal with that. So the energy regulators and the governments are changing that by telling you that your electricity price at which you purchase energy is about, let's say, 60 euro cents per kilowatt hour, and if you give it back, you get 5 cents. So you buy at 60, you receive 5. It's ridiculous. You don't want to give it back. You want to consume. So you want to consume the energy you're generating. One of the things we're doing that is via thermal buffering. You heat up the water tank of your heat pump, and basically you buffer pure in terms of heat. User profiles. We're starting to add into the equation user profiles. If your son is arriving at home after school, he has a different use of your house than if your wife is arriving in the evening, if you're arriving in the evening, if you're arriving in the weekends. Your son has to go to study, you can go cooking, your wife can go to her office in the home, I don't know, whatever. But it's different user profiles that we have to keep into account to know which energy will be needed in which room. Weather forecasts, again, with the flexibility, with the variability of the sun and the wind, we need to know weather forecasts to know when energy will be cheap. We now have contracts. You see that from your side on the right-hand level. Dynamic tariffs. So we now have contracts with power suppliers, and whereby we know the price of electricity every hour for the next 24 hours. So we know when it's going to be the cheapest to charge your car or to basically heat up your thermal buffering. So there's lots of things that you have to put into the equation. And so if you look for an EMS, for an energy management system, it should be a smart one that takes all of these into account. It's not just about, oh, you're consuming, 2 kilowatts, and now my solar panel has to generate 2 kilowatts. No, you have to be able to forecast. You have to be predictive. Yeah. It's also important that you're going for one energy management system. You only can have one boss if it has to do the overarching role of managing your energy. You cannot have a separate app to run your thermal buffering, your heat pump, and a separate app for your charging station, and then a separate app for your energy management. They all have to work together. Very important. Also, it's very important to give back control to the end users. End users have no idea what's happening. They have no idea what they are expecting on their energy bill. It used to be very straightforward. Yeah, back in Europe, we have night tariff and day tariff. I think here you have it as well, but only for the bulk buyers. I don't think you have it residential, if I understood correctly. With us, you have night and day. So everybody knows, okay, if I turn on the dishwasher and in the evening and the TV, etc., if I do everything after 10 o'clock in the evening, it's fine. I'm not going to pay a lot. That's not the case anymore. The whole point is you don't want to turn on a lot of things together. You have to reduce the peaks. Yeah? So how do you give back end user control via energy management? How do you give them a visualization that makes it understandable for them what's happening in their homes? If we look at the evolution and the types of energy management systems, there's different kind of types. Level 1 is what is read, is the dongles. We start seeing a lot of dongles now that you put into smart meters, and that dongle is sending data to the cloud, and you can see how much energy you've been consuming. Pretty straightforward, nothing smart about that. Second level is interpretation of the data. You have other dongles that not only show you how much you're consuming, but they can send you notification. You can say, look, if I'm consuming more than, I don't know, 4 kilowatt peak, send me a message because I want to know, I want to see what's happening. Okay, it's going to send you some notification. Third level is control. It's not only notifying you, but doing stuff. The system, the energy management system knows that you're consuming too much, so it's going to shut off certain things. Or it knows that you're generating too much, doesn't want to give it back to the net, it's going to put your heat pump in boost and do some thermal buffering. Fourth level is predictive. Okay, it's forecasting based on data. It is knowing that you are putting in your electrical vehicle, knowing that your electrical vehicle does not need to drive for 6 hours, but that tomorrow you will need to drive at least 50 kilometers. So it will then say, okay, and I know that the energy prices between now in 3 hours will be cheap for 2 hours in a row. I'm going to not charge right now. We're going to charge full in 3 hours. That kind of information is prediction of charging, prediction of energy consumption is the latest step we're currently working at in terms of energy management. Now, as was explained in the introduction as well, energy management is just one part of smart homes and buildings, but it is kind of the gravy on everything. It's the sauce on all of the other technical subsystems, because energy management is only relevant if you can control and read out lighting, HVAC, screen data, all of the stuff, all of the technical subsystems that are available in your home. Yeah. And so we'll go into that also in a couple of slides. Now that we have seen a little bit the evolution of the market and where we think it's going to go, let's use a couple of examples of examples that we know very well of our own system. Just quickly, what do? We are Cubus. Cubus is a company that started in Belgium in 1999. So we've been in the market for 24 years, almost 25 years. We have made more than 30,000 homes and buildings intelligent. Now, we don't install, we produce. We are the manufacturer. We produce the controllers and the dimmers and the software, the data forecasting algorithms, etc., that we resell via installers and distributors into the homes and into buildings. Our goal is to make buildings smart, and that means energy efficient and comfortable, the sustainable comfort. Peace of mind, also very important. Peace of mind for the owner of the building, for the CEO of a company, that the employees have a good place and a safe place and a secure, comfortable, healthy place to work at. But also for retirement homes, that if something happens and they push a button, something will happen. It will a message will be sent out. The doors will open. So if you hear that your neighbor is in distress, you don't just stand there and don't have the key. So all of that stuff is peace of mind. And then compatibility, very important. You want to make sure that your system can keep growing. You have to remain compatible with your initial installations. As I'm saying, what we want to be is the preferred supplier of automation solutions. So automation solutions is not only hardware, it's also the firmware in it, it's the software in it, and it's basically, we want to make the integration of technical systems more accessible and easier. We will need to move even more to integration of technical subsystems, but we have to do it in an easy way, not with the most complex software that only few people can do. It has to be accessible, it has to be easy. We are also, part of our business is also energy management. The system is being used, among others, as energy management systems. Why? Because we do control of HVAC, we do control of water, we control lights, and we are in the enclosure in a lot of homes. We have the established network, we do all of the development ourselves, have the local support here as well in Sri Lanka, for instance, from Oral Company. So I think we're an ideal partner to work with, and we continue to develop via our own guys. Our own development team continues to develop all these new things that happen in the market, like energy management systems. So just a little example of Lucas. Lucas is a universal energy management system for residential. We have some more information about buildings later. But basically what is Lucas doing? It's managing energy streams. And the best way to show you that is to actually show you our user interface. I'm going to share my data. Just hold on for a second, please. Screen sharing. Voila. And mirror on the wall. Voila. So if we start looking at this, so this is basically now the office that we have back in Belgium. Here you see, so Lucas, it's a module, it's a Dinwell module. And what is it doing? It's basically managing your main consumers in a home or a building. Main consumers in homes and buildings right now back in Europe are heat pumps, the heat pump of the building, and the electrical vehicle chargers. So what you see here on the left-hand side is first the general measurements of energy. So currently we are buying from the net 7.2 kilowatts. And when I click on it, it will give me some actual data. Go to 24 hours. It will give me some data on, okay, what are we purchasing from the net? The white line, the white graph is telling me that I have been importing 3.5 kilowatt yesterday at 10 o'clock. Yeah. The black line that you see is the maximum limit that we've set. We have set a maximum limit to purchase no more than right now 17.5 kilowatts. We want to purchase no more than 17.5 kilowatts from the net with our company. Yeah. You see that the white line is following, pretty clearly the maximum that we've set. Why do you want to set this maximum? Because we have 30 kilowatts of solar on the roof. If the solar is generating, perfect, if it's generating 10 kilowatts and we want to purchase maximum right now, let me check how much, where we put the maximum level. Yeah, okay, they have, we want to purchase maximum, let's say 7.5 kilowatts, we can purchase 17.5. That's what it knows. If 17.5, if we have cars coming in and cars plugging into the charging stations, and we have a base load of about 4 kilowatts of consumption. When we add a car, it's another 5 to 6 kilowatts. So if we add 3 cars, the system will see, okay, you're consuming too much. It will start balancing the car consumption. It will tell you, it will reduce the power that we give to the vehicles. It knows as well which vehicle has priority over which other one. So if you have a vehicle that needs to leave in 2 hours versus a vehicle that needs to leave in 8 hours, it's first going to reduce the power towards the 8-hour vehicle and put everything in the 2-hour vehicle because this one has to leave. So it's a lot of data that's taken into account. It's data that's taken into account to basically manage the main consumers being vehicles and a heat pump. You can see, for instance, on this one, there is a car. A car is connected, but it's not charging. It's not charging because it is, we don't have enough energy left to deliver to the vehicle. And probably because the vehicle does not have to go anywhere in the next couple of hours. So it says, okay, it's not charging. If for some kind of reason you want to override the system because you have to move faster or whatever, you can obviously change it to manual mode and then power it up. Yeah, that's basically what the system is doing. It's also checking your heat pump. So your heat pump is in automatic mode here. If we're consuming too much energy, it will reduce the heat pump to an off mode for a certain amount of time. If we are generating too much energy, it will put the heat pump in a boost mode. It will increase the temperature, so it's going to save energy in this heat pump mode. It also gives you the opportunity to take a look, give you all kinds of insights. As I was saying, for an end consumer, now we're talking homes, we're not talking building, but for an end consumer, we are getting, end consumers are getting lost. They don't know what's happening. So we want to give them insights. We want to tell them, okay, what happened in October 23, last month in your home or, a small business? How much have you been consuming? Again, to put it into perspective, this is an office, this is our R&D office, our headquarters. We have about 40 people working there and 4 cars charging. So our total consumption in the month of October was 2,400 kilowatts. Or we can check in euros, 617 euros, okay, which is not cheap, but okay. We've injected, so how much did we inject into the net? Okay, we injected 200 euros, which is a lot. We want to basically use everything, but still we injected 200 kilowatts. What was the quarter peak? As I was saying, you are getting stimulated now in the market to reduce the peak. The government, basically you get a free peak of 2.5 kilowatts. Every kilowatt that you're above 2.5 kilowatt, you get charged at 40 euros per kilowatt, which is quite a lot of money. So if you have a peak of 10 kilowatt by putting a vehicle into the car charging station and having the service running and you want to cook, etc., you're getting a peak of 10 kilowatt, you're going to be paying 7.5 times 40 euros, a lot of money. So here we have lots of insight. You get tips and tricks, general tips and tricks, saying, your slumber consumption is low, perfect. It's no more than, it's only 2.8 kilowatts. But, another tip could be that quarter peak. Yeah? There's a big change. There's a big difference between your maximum peak and your slumber consumption. So, we give some suggestions on how to reduce this. It tells you also what the energy management module has done. It has auto-consumed most of your energy. It has intervened 268 times. You didn't do anything. It's the module that's in the enclosure that intervened 268 times in the month of October. It reduced the power towards the electrical vehicle chargers because you were consuming too much. It buffered energy into the heat pump because you were generating too much. It sent you a notification because even after turning off the power to the vehicles and turning off your heat pump, you were still over-consuming, and that is going to send you a message because you do not want the you do not want the energy management system to turn off the oven or to turn off the stove or the washing machine. That you don't want to, that you have to control, but it will tell you to do that. So we have insights, we have charts, lots of different kinds of charts, giving you information about the consumption that you've had. Let me go to, for instance, the actual. Here we go. It takes some time to read out, to take up. So yeah, I don't have a very clear image here. Let me reload this for a second. Can I reload this somewhere? Voila. So basically, it can show you also the detailed energy graphs of how much we are consuming. What was the, let me go to the charts. Voila. It can show you the power, how much power we've used, the actual the actual purchase of energy, during the month of November, which is almost finished. We know that, yesterday we've basically purchased a 98 kilowatt hours. 31 on peak, 98 off peak. We can check the what else do we have? The injection of power. How much did we put in versus how much did we inject into the net or use from our solar panels versus buying from the net? Yeah. Take some time to upload, but I mean it's giving you all these overviews and all of these different ways of showing what kind of information we have. It's giving you the peak. What is the highest peak we had in the month of November? Yeah, what was the highest peak that we had and which day in the month of October? So it's giving you all this kind of insights and solutions, again, mainly focused on homes. Yep. So that is an example of an energy management system that is being used, pretty frequently now in the last year, both in Netherlands and in Belgium. As I was saying, where do the energy management systems get their data from? There's two options, or you have a smart meter. We have an evolution of smart meters, an increase of smart meters. By end of next year, 80% of the homes will have a smart meter. Today, 50% of the homes have a smart meter. So it's already a lot. And we get the data out of the port, the P1 port from the smart meter via a certain protocol that's been defined. That is another issue because, again, there is no standard across Europe. Belgium has a certain way of talking to P1, in Netherlands, Germany, they all have a different way. So it's all a matter of the manufacturer to make sure that you integrate all of these different standards. Obviously, in buildings, we don't have a small smart meter. We have high voltage or medium voltage. We also can connect kilowatt-hour meters into this unit via Modbus or via pulses to basically read out the data on that level. So we read out, we connect with a smart meter or kilowatt-hour meter. We connect with electrical boilers or electrical heat pumps. Two ways of connection are possible, or smart grid ready. Most of the new heat pumps that are coming out have this interface called SG, smart grid. It's just two contacts, very simple, but it is a standard among the heat pump manufacturers that they provide these smart grids, two contacts on each of the heat pumps. And with the two contacts, you can basically control 4 modes, right? You have your normal, off, boost, and economy. And that's basically how you can communicate. Very, very simple. We can also communicate via Modbus. But the thing is that we want to make life easier, and also the heat pump manufacturers want to make life easier for the installers. So if you have to ask an installer to do Modbus configuration, it's a lot more complex. With this smart grid, it's just on-off, and it's just some modes that they're sending out. You also want to connect your energy management system with the charging stations, with the charging station for your vehicles. How do you speak with these guys? It's mostly via TCP/IP. TCP/IP protocol is being used by a lot of the charging station manufacturers. It's mostly Modbus TCP/IP. Some of them are using serial Modbus as well, but again, in our experience, 90% uses Modbus TCP/IP. There are protocols being developed, OCPP, etc., but they're not really on the level where they're being used massively for the time being. We can add additional meters via pulse inputs, gas, water, so we have a total energy overview. Obviously, you want an app, an energy management system without an application that tells you how much you're consuming, forecasting, gives you notifications is not working. So you have to have a connection with an app. And very importantly as well, is that you want your system to be connected with the app. Of course, you need internet for the app, but also just in order to be able to deliver over-the-air updates. Because the market is changing so fast that in the next couple of years, you will have different kind of requirements, different heat pumps, different charging stations, different protocols, algorithms that are popping up all over, and you want your module to grow with that market and grow with you. So that is it's important that you can. When we launched this Lucas module, we had 3 heat pumps and 2 charging stations. We've launched them now about 10 months ago. In this 10 months, we grow to about 10 heat pumps. We have inverters, batteries. We have several charging stations that also can work together. If you have multiple different charging stations, we can balance across the different range of charging stations. We have dynamic pricing, forecasting, etc. So you have to be able to update these modules from time to time. It's a pretty broad brand compatibility. You can all read this if you want to know more. You can find more information on the website. But again, and this is what I explained to you. Now, when we go to buildings, in buildings, when we do energy management in buildings, it's different. You cannot just come in with a module and say, here it is, and it will run. You need to be able to do your homework. And you have to do basically an audit, an energy audit, where who is using what amount of energy in this building, which circuits are being used where, and which circuits are consuming more than expected, etc. So we basically go in, use CT connectors, clamps around the energy circuits, and we start reading out. We start reading out for about a month, and so we know who is consuming where, etc. And based on what we read out, we can give certain insights and certain analysis and improvement opportunities to this building. And this is an example. I'm not going to spend the whole video. This is an example of the dashboard that we've developed for this energy management, for commercial energy management, whereby you can select basically, it's a chart where you can select which consumption, which part is consuming how much, if it's the main floor, the lighting, or the charging stations. You get an overview of the total energy consumption, but split up over 24 hours. When are you consuming most, and how much are you consuming there? You have pie charts showing you the largest the proportional consumption of each of these. We have dashboards, not only the overview, but you can also dig into the dashboards that are showing you only on one of the distribution boards, for instance, in the last 12 hours, 24 hours, you can select the timing. You can find out how much has consumed on which level. Here we're checking the basement distribution boards for the last now 24, last 2 days. What is this? Where is this coming from? Does this make sense or no sense? Yeah? Okay, I can give you some examples of the analysis that we could do, or the things that came out of this. You can also check all of the meters, of course, everything. And then you can score, you have the momentaneous consumption and you have the total consumption since we started to measure. And you can check that obviously in all of the circuits, be it the charging stations in that this is a shopping center, the parking lots with the charging stations, the lights of the parking lots, the lights of the logos on the highway, etc., etc. You can basically read out the whole thing. Let me proceed to the next slide. So energy management is one. As I said, you cannot look at that individually, separately from other solutions. HVAC control, huge. Most of the commercial buildings, the biggest part of their consumption is HVAC. In Europe, in continental Europe, we have both. We have airco in the summertime. We have heating in the summertime. We have the issues that you don't have here. We have issues that in lots of older buildings, they have two systems, cooling and heating, with separate thermostats that are fighting each other. So we have had installations where they're just throwing money through the windows because, when the heating came up, the cooling started to cool down, and then the heating started to move up, and it was ridiculous. Yeah? Here you don't have heating, but I assume maybe in the mountains, in the Norelia or something, you might have heating, but cooling here is also a pretty big part of your energy consumption. You need to have, we do lots of cooling installations as well, cooling and heating installations, where you do both the primary and the secondary control, setting up the curves, having the valves, three-way, two-way, all kind of valve control, having zone-based heating, having sensors in the rooms, into the switches or into the motion sensors, measuring temperature in certain areas, and basically controlling the heating and the cooling based on that. Obviously, all combined with ventilation. We use a lot of what we call fresh air ventilation, whereby we basically take air out of from outside. We heat it up over heat exchangers and then blow it into the area. Obviously, this is heat combined with convectors and ventilation, where you don't want to get into over or under pressure, so you have to extract on the same levels. All of these calculations are done with our HVAC control system. We have user interfaces, all kind of user interfaces to check the channels. I'm not going to spend too much time on that one as well. And then the last one that's also this is pretty new. It's coming. It's popping up more and more, and it's perfectly in our line of energy management and smart buildings or smart homes. It's pool control. So pools, when you look at residential pools or hotel pools or whatever. But pools are a huge consumer of energy, especially when they're heated. heated pools, you know, you just heat the pool. When you think residentially and people have pools, they're heated up and they're swimming 3 times a week or something like that, right? So this pool control system is taking into account user preferences. When are people swimming? It can detect it based on the water movement. When are people swimming? What is the weather forecast? What are the dynamic pricing? How much is energy going to be priced in the next couple of hours? The consumption of the house. How much is the house generating and or consuming based on historical data? Yeah, and it will send all that data to the cloud. It's working. It's basically processing that data in the algorithm, and it's sending once or twice per day. It's sending a control program to the pool controller that makes sure that your pool is warm when you swim, but is not overly consuming energy. Again, sustainable comfort. It's a module. It's a control module in the pool house. That is controlling the heat pump, controlling the valves, it's controlling the water filtration system, and it's controlling the pump, the circulation pump of the pool. You can connect your shutter on top of the roof. You can connect the lights. You can connect a lot of different things, all resulting in forecasted data. This is not historically how it was. This is how much the temperature will be in the next 7 hours. What the heating capacity of a heat pump is being forecasted via the system. And obviously the energy savings are also shown to the customer, as well as the pH levels and the temperature evolution and so on. So again, that's it. I kind of ran through it because I know it's late and you guys want to, you know, have a drink and go home. But I think the core of this whole thing is that we see electrification, the way energy market is evolving is reducing energy, but more electrical. The good news is electrical you can control, and the control is all focused on sustainable comfort. How can you control something to provide less energy and to provide more comfort to the users, be it a business or a residential user? But energy management encompasses a lot of separate things. Could be HVAC, could be lighting, could be screens, and it's basically the integration of all that makes good energy management. That's it. Thank you very much. If you have any questions, shoot.
That's I want that maybe engineer, and the customer will ask me why is this code? Okay, so then now you need the maximum demand we want consider. Okay, area is not demand consider. So what are the things that as a conclusion can you say that what are the things?
Well, for smart home, it is mainly then comfort functions. So you can have some energy savings, of course, by not having the airco running when you leave, for instance, the home, yeah, and you have an all-off button. It automatically can put your airco to 26 degrees. So it's not running at 22 and you forgot. Okay, that's an energy savings argument. But we've been here for 24 years. It's only since about 1 year since the government started imposing these energy savings measures, and that you have to have an electrical vehicle and you have to have electrical heat pump. It's only then that people start thinking, okay, you know, now it's all about energy efficiency. But before, it was all about comfort. How do I make sure that I use motion detectors to turn on my lights in the middle of the night? I walk into the bathroom, you know, and I don't have to look for the light. It goes on automatically. It is safe for me. Yeah. I can do presence simulation. I can pretend if I leave my home, I press the off button, the lights will pretend that somebody's home. So it will suddenly one light will go on, another light will go off, etc. So it is showing to the outside world I am home. So it's security. So it's safety, security, it's comfort, and it's a part of energy savings.
There is some kind of case study for the local system.
In Sri Lanka?
Yeah.
Oh, we have done multiple homes in Sri Lanka. We have lots of cases. I think we have even a video with Mr. Murat, no? Yeah. So we can show that. That's not a problem.
There was so many other devices that you mentioned by like carbon and things like that. There are a lot of second third-party devices. I'm asking, I did it in one of my personal projects. I would like to know your experience in your country. The problem is when you are taking this cable to this particular device, provided by the third party, the simple answer we are getting is that no interface. Yeah, so these are huge power you can provide this communicating strategy to we have a controller, but most of the third party devices are not. Your experience if you like,
Yes. We have a similar situation. Well, we see that a lot. The thing is, one of the problems in home and building automation is that there is no standard. Okay, people say, oh yeah, of course, there's Modbus, there's Loanworks, there's BACnet, there's KNX. The fact that there are so many, there is none, right? There is no standard. The only standard you have is IP. So for us, the focus is the control system could be multiple different standards, doesn't matter. But the way the integration happens is mainly via IP. And that's what we've seen. You can have different ways of integrating. You could integrate via BACnet IP, via KNX IP, via Modbus IP solutions. That's more complex. On the other hand, you can also have a more high-level integration with integration modules. We had to develop our own module. It's called UBI. It's an integration module that detects the IP systems in one environment. So the module is connected to the network, and on the network, it detects the supported, not everything, but the supported IP devices. So it will find your Modbus IP, your KNX IP, and so on. So as for the user, he has one dashboard, and he can see all of them independently of the protocol behind it. Could be KNX, could be QBus, could be Modbus, it doesn't matter. But it also detects what we call smart devices, some Sonos home music system, or a Bose music system, or Google Home, or an Alexa, because these guys are also popping up in the market. That's how you can integrate these. When we have third-party systems, if they have absolutely no integration capacity, we try to avoid them. Very simple. Most of the professional third-party systems, they can integrate somehow, be it with more technical integration modules such as Modbus or BACnet, or be it via an API or something software-based, IP-based. There's a possibility for integration. The ones who have zero integration opportunities, again, as I said, we try to avoid them.
What would be the minimum data period that you implement for the existing public system?
For an existing building to do renovation?
Yeah, then in Sri Lanka, so that existing.
Yeah.
Then we are going to connect it to the smart building. What would be the possible data periods?
It depends, of course, on what are you controlling. If it's only lighting, yeah. If it's only for lighting, I think you're better off just having LED relighting with LED lamps, and that's going to be easier. And if you, as soon as you start integrating HVAC, yeah, and we know that by basically having an HVAC system based with local temperature zones, so zone-based heating and sensors. So we've done several installations, for instance, in bigger buildings, whereby the presence is detected in a certain area, in a certain room, and in that area, then the HVAC system is turned on. Only in that area, not in the entire building. So that's a combination of presence detection and room-based heating. We save about 35% of the energy cost. Yeah. So on average, it happened that it was 19%. We've had 56% in the UK in certain projects. Let's say 35% average. So if you have to calculate your ROI, you have to just figure out how much energy is this company consuming and what's the cost of placing these modules. Normally, if it's a new build, the cost of the modules versus the savings that you do, you'll have less than 2 years of return on investment. In existing buildings, we don't know, and I don't know the cost, especially the labor costs of rewiring, because you have to rewire a lot. In Europe, this becomes prohibitive, because the labor cost in Europe, it's too high. You would pay approximately 50 euros per hour So 50 euros times 300, that's 15,000. 15,000 rupees for every hour somebody puts a cable. It's not going to work. Here, the labor cost might be lower, will be lower, and so maybe your return is going to be better calculated. But it's something that you have to evaluate. But 35% on HVAC, that's a savings that you can do. And we also know that with motion detectors in the hallways and turning on the lights on and off, you can have about that's not 7%, no 13% of savings with motion detectors, with lighting control. That was lighting control, not with LED lamps. Yeah, but again, it doesn't matter. At the end of the day, your percentage is going to be the same, but your energy consumption of the LED lamps is going to be pretty low. So this 13% is not going to amount to much. So I was focused on the HVAC and trying to calculate it that way. No more?
Yeah, Sri Lanka is some other third world country, which with the GDP per capita like 400. The meantime, there is far below the developed countries in the range of 12,000, but still, when it comes to the electricity cost. We are in the range of, we are very much close to Singapore and Hong Kong. So, in that aspect, when are considering from that angle, I believe that the importance of this kind of a control is much more importantly than the domestic level in high-rise buildings in the city. So, because those have very complicated control systems, related to HVAC and pumping and elevator systems. So, do you have, since those have some sort of complex controlling, is this the kind of system capable of handling all these parameters together and optimize those with this kind of a system?
Yeah. Yeah, we see that. That's a good question because we actually see that as well. We back in Europe, we're also moving away in high rises or in bigger buildings. We used to have individual, especially heating and cooling. We used to have individual heating and cooling plans per apartment, per an individual system per apartment or per room less, but especially per apartment in high rises. They're moving away from that because that was too expensive. So what we see in evolution towards collective heating cooling systems, especially in high rise. I'm not sure how much that happens here, but we would have a collective, especially heating system, and that collective heating would go up and down via the pipes to all of the individual apartments. And individual apartments, they are just taking heat or cool water from the collective provisioning. And we've done both of them. We can basically, we have controllers. Yeah, one controller can go up to 150 Qubus modules. So if you would look at a hotel, for instance, we have guest room management systems. Yeah, you would have one guest room management module per hotel room. That will mean that we have one control unit for 150 hotel rooms. We also have to take into account distances and so on. But to give you an example, we have installations. The most complex installations that we have are up to 35 Qubus controllers, which is like a retirement home, a pretty big retirement home with about 250 rooms back in Belgium. We have done prisons of 1 square millimeter of surface, where we do the full control of the prison cells, the heating, the CO2-based ventilation. So we can handle that, and there's other systems that can handle that for sure. Both with multiple individual heating and cooling systems, but also the new evolution that we see, whereby we control the primary cooling and heating system, the primary heating and cooling system, and where we do the secondary based on temperatures measured in the rooms into the apartment, and running valves that are on the main pipes up and down. So the long answer to your question that yes, it's absolutely possible to do that. I did not know that Sri Lanka has such a high energy price compared to the GDP. That I don't know. I'm pretty sure that's also because Sri Lanka is energy dependent. About 3 to 4 years, we had once a presentation, remember, where we explained that it's stupid. It's not a smart thing to do, yeah, to be energy independent, especially in a country like this where you have sun and windmills all over, and wind. So, okay, but that's politics. I don't have to be involved in that one. But I would assume that is the consequence of being energy dependent, that your energy prices are high. We know that GDP is lower, so when we do projects in Sri Lanka, we don't do many residential. We do some, but again, it's expensive compared to GDP. But we do quite some projects in hotels, in ballrooms, and things like that, factories that we equip, and then again, currently it's still mainly focused on the comfort of the guests and the people working there, etc. When we're talking about building management, but it will evolve into energy. It will evolve into energy savings. And if, like when I was answering this person, if you can, you just calculate 35% on the heating costs, on the cooling costs, 35% on cooling costs, it's a pretty big jump in the budget of a commercial building. And the investment is not going to be huge to control for HVAC control. We're not talking about $50,000. We're talking $2,000, $3,000, $4,000 to do this HVAC control. So if you can save 35%, that means you have an energy bill of about $15,000 in a year, which is large, I know. But in bigger companies, if you have $15,000 per year energy bill, you have a return in less than 1 year with such a system. Not only ours, there's multiple other systems as well, but that's certainly worth to take a look at it. Lighting is difficult. I think the return on investment case for lighting control in order to save money, if you already have LED lights, etc., it will take longer. That might take 4 to 5 years for return time. But for HVAC, for sure, it's going to go very fast. Is that sufficient?
We have to live with BSESC system. One side. Another side, we have a management system. So, if I can combine these two systems, integrate, so I will control something to get benefit of like controlling maximum demand.
Yeah.
So, giving someone access to these two systems. So, do you have any suggestion on this moving product?
A suggestion on?
So, do we have any product or any
To combine that?
by
I don't know which systems they are, so we have to take a look at it, but it's extremely important indeed if you have a situation like this, that you have your BMS system and a separate energy system. That's what I was explaining. That makes no sense, because your energy is just telling you you're consuming, and you have a control system, but it doesn't talk to each other. So you absolutely have to, I would do whatever. You don't have to throw away your systems, but we can give you some suggestions, but I'm pretty sure that if you talk to or the energy management company or the BMS company, if it's a BMS, it should be a bigger one. They have some way to integrate to the energy, and even if it's just with open contacts, if it's just a basic solution that, we're consuming too much, so we'll reduce something or we'll shut down certain circuits, that will already be extremely beneficial. I cannot tell you right now how, what solutions we would have, because again, I don't know the interface possibilities of both systems. But the need to integrate is extreme. I would strongly suggest to proceed. If you want more, you can always send me. Give me my cards. You can always send me some information, and we can take a look. But I'm pretty sure that, if you already have two systems, I don't see the need for a third. I'm pretty sure that these two could be integrated with probably a solution from each of them. I would be very willing to supply you an entirely new system from us, but that might be, good for us, but not great for the customer.
Any answer?
Yes.
This is what advice for the place of you. Actually, Sri Lanka is currently under crisis that you know. So, we as an engineers are now evolving energy how energy. So, unlike you are now discussing the smart energy arrangements, we are acting on the energy Sri Lanka. So, what I was asking is now we have kind of the regulation there. We are starting this energy management. We are doing the energy auditing. So we have daily circulation, substation energy, which are important also. These are our baseline, base references. So what is your best advice unless Sri Lanka? Because why I'm asking this question, still we have no proper regulation, or initials or as you mentioned, we have the energy mechanism. So that is the achieved by individuals, but we don't have. So unless tropical countries, Sri Lanka, what is your best advice to establish centralize this energy management system? Because now we should start from the energy management, not call it smart energy. We have both, think about that. So we should start good energy management system, centralized, like in the regulating the energy system. What is your best advice?
Are you talking from a political point of view or?
That's political, as we have now. We as engineer, we are the, so we should propose, politicians are there.
Yeah, I would start with not becoming energy dependent. That's one. And I don't know the market enough in detail here, and I don't know the politics enough here, but I think what we saw very clearly is that if it's very difficult to change people's behavior if there is no legal framework around it, there's no legal push around it. Yeah, and that's I mean, it all depends also on the energy infrastructure. The energy infrastructure back in Europe, because we're going to this electrification, because we are tripling the electricity consumption in the next 4 to 5 years. The architecture, the network for energy supply cannot handle that, and that's why the regulation said, okay, or we have to build an entirely new energy delivery network, which is too expensive, it's not going to happen, or we have to reduce the peak, you know, because it's like, I mean, it's like a water pipe, right? If you have to be able to at once every year get, I don't know, 20 cubes of water in 2 minutes, you need a huge water pipe, even if for the rest of the year, if there's only water dripping outside. Same thing with energy. If you have peaks up to 15 kilowatts, we have to be able to supply you up to that peak. If your peak is reducing to 8 kilowatts, yeah, but even though you're consuming as much, it's going to basically free up the 50% of the capacity. So it will depend on the local energy network and the local, you know, energy regulation on where do they want to hurt people, or where do they want to punish or give presents to the people on how they are consuming their energy. Peak shaving is always a good solution, because the network is built on the top capacity, and so if you reduce the peaks, that's a lot better. Auto consumption is great. I mean, here in Sri Lanka, you have, I mean, I don't understand there's no more solar panels, honestly, because, you know, it would be very easy to put the solar panels or have some kind of legislation that requires in new builds to have a certain level of solar panels. I understand there's lots of high rises in Colombo, yeah. But even with us, with solar panels back in I would say Europe, I'm going to take Belgium because I'm sure about that one. Also on high rises, we have solar panels. We have solar panels that are being used only to cover the communal charges, the power for the elevator, for instance, or the power for the lights in the hallways. It's not a lot, but it's already something. And the third thing that we're doing is energy sharing. So what you do is you put if you have, let's say, industrial environment and industrial building sites, right, not far from where you have high rises, residential high rises, The industrial guy, he can share energy, he can resell energy to the high rises. Because the industrial company, they have the roof, yeah, they are consuming during the day when nobody's at home in the apartment. So then the limited number of solar panels on top of the high rise is sufficient to cover the basic energy needs in the high rise. And in the evening, yeah, when people are coming in the evening, you can use energy that was generated or that is even stored in batteries from this big commercial building. You can use it, they can resell that to the residential high rise. So basically, again, a long answer, but I think thinking forward, thinking about the fact that there will be a lot more electricity needs in the future. Maybe you could say, yeah, but you know, Sri Lanka is third world country and it takes longer to get there. It might take longer, but it will get there. So in 10, 15, 20 years, you will have maybe less consumption of energy, but a lot more will be electricity. So in terms of governments and regulations, I would take that into account, figuring out if we get there to that level of electricity, if we have to triple electricity consumption here in Sri Lanka, what is the implication to the network? How can we reduce that implication by having this peak shaving? How can we find solutions where people share energy with each other? And how can we tax energy in a level that people are stimulated to reach or to basically achieve what we want them to achieve? That would be my idea. And build solar plants and windmills in Sri Lanka.
Thank you.
Okay, that's it. Time for beers? No? Okay, no time for beers then. Okay, thank you very much for your attention.